Hey everyone, thank you for joining. Welcome in this talk, which is essentially 1 hour of myself talking about a very, very, very deep nerd snipe into a rabbit hole, actually, of streaming online audio to my Sonos speakers that I have at home. Before we start, I want to quickly give you a disclaimer. I will share some bits of source code where they matter. I will show you a couple of thoughts, but I will not share the full application that I built, because I think I broke some license agreements with this thing. So let's make sure that this doesn't hit the internet. With that, let's start. So back in January this year, essentially when we moved into our house, we bought a couple of living room speakers to make sure that we had audio for TV, that we could stream radio and things like that. But in January this year, we were thinking about replacing those old speakers that we bought when we bought the house here. The old speakers were actually old PC speakers. They gave a decent amount of audio and so on, but it was not very handy to put up some internet radio or something like that. So we thought, let's replace those with something new and shiny, and let's replace them with something smart as well, because we stream a lot from the internet, from a lot of different radio stations and so on. So I wanted to have something that was connected to the internet and could stream from there as well. The requirements would be 2 of those speakers for the living room, but since we were renewing anyway, we thought of, well, maybe also adding a couple to the home office, because then, we spend more time there this year anyway, and let's have this continuous group of speakers where we can just roam around the house and have the same music and audio playing everywhere. So we fell on some Sonos speakers, the Sonos 5 actually. And we looked at the price and we were thinking, okay, maybe for just 4 speakers, that may be bricks in 2 years from now if Sonos decide not to update their firmware or whatever. That's kind of expensive to buy with that in mind. There have been cases of lots of IoT products and so on where support is discontinued. So we didn't want to spend this amount of money on speakers. So now what? Until the day we were walking around in an IKEA in the neighborhood and we found those Symphonisk speakers that they have. I don't know if they have them in Australia, but it was kind of nice because they looked like Sonos speakers, and we looked at them and they were actually Sonos speakers as well. Same hardware, just in an IKEA box essentially. Same software. The application to control them was the exact same application that you would have for the other ones. And they came at less than half the price. So that was really interesting. They sounded well. So we took them home in a cardboard box. We read the manual, we installed them, and we followed everything that was in the manual. So we sat in the sofa and we started playing some audio. We installed the application and we found it on the Android Play Store or on the Google Play Store. We installed it. We started playing things. We used Spotify. We used our typical tune-in radio, things like that. Everything worked. We were really in love with this entire setup. So good. Except for this one thing. There's this online video site, and I'll name it anyway, on YouTube, where there's a lot of video clips. And usually what we did was play those video clips, not for the video clips, but for the music that they contained. And I tried playing music from the video sites, and that didn't really work. So we were thinking, okay, smart speakers, and they can't play something from the internet, which is their main promise. And that kind of sucks. It's not very, very ideal. So our honeymoon phase was kind of over and we were grumpy cats. So now what? And I made this slide intentionally look bad because that was what we felt. We were searching online for solutions to playing video from this website or audio from these video websites. And all we could find really was excuses from Google blaming Sonos or Sonos blaming Google and legal and patents. And really, I didn't care. I just paid a lot of money for speakers. I just wanted this to work. So now what? Searched a little bit on the Play Store again and found a couple of apps that were able to do this. But first of all, they were paying. How dare they ask for $3? Second of all, I would expect that I could use the app that I'm used to and just press share there and play on those speakers. And this was an entirely separate app with different kinds of permissions, with different ways of navigating around the website and so on. I wanted something simple and not something that would replace the app that we were actually already using. Again, also with the risk that some APIs would break and this app would break over time. So I wanted something that actually worked. So I started looking into the documentation on the Sonos website and found that they supported a variety of audio formats, including MP4. Now, my idea was that this video website would play MP4s because those are videos and that's the typical video format that we use online. So yeah, why can't I send MP4s to this Sonos device and have them play? So this is where the nerd snipe started. I'm not sure if everyone in the audience is familiar with the term of nerd sniping, but it's essentially giving someone a time-consuming problem that they will dive in completely and that they will try to finish until the end, but that may take a while and that may be complex and so on. And it's really, yeah, putting someone on a different track and hoping they finish. I do this often with colleagues. Colleagues do this often with me, but this was essentially a self-nerd snipe where yeah, I put myself in that situation of researching and essentially getting that MP4 file to play on the speakers. So I started doing some research and thinking about what I would need. So I would need to be able to connect to the speakers, first of all, have a way to interact with them and send data to them, a way to get the MP4 URL of that online video, get a way to send that URL to those speakers, and then essentially enjoy the music. So I thought 3 simple steps. How hard can it be? Turns out that there's a lot of things on the internet, and if you Google around, there's a lot of things that you can find that will work out of the box. And I found this SOCO library, the Sonos controller library in Python. And it allows you to discover speakers, first of all. It allows you to change the volume of the speakers, play music, send URLs to them, and so on. And this really sounded great. And I thought, okay, let's install a Python runtime, give their hello world a try, and send some MP3 file or something to those speakers. So I did so, downloaded it, connected to one speaker essentially. In the main method of the Python script, I started or created a new SOCO class connected to the IP address of one of the speakers, sent it a link to an MP3 file that I had on my local web server, and it all worked. Very promising. Everything worked. I could connect to this thing essentially in 5 lines of code and have it play some URL. Of course, an app would be nice later on, but so far this works. So proof of concept wise, the first step of connecting to those speakers was already finished and was working. The next step was getting the MP4 URL of the online video. So it turns out that if you play a video on YouTube, that ID that you have in the URL is something that you can also use for another endpoint that they have, the get video info endpoint. If you pass that in, what you will see is a giant bulk of URL encoded data that is being returned with some JSON sprinkled in that is also URL encoded and so on. It's really a crazy format. But somewhere in there, you will be able to find an element that is named streaming data. And in that streaming data, you will find one or multiple video formats and audio formats with a URL to the actual MP4 file and their MIME type, so you know what data type it is. They have some audio-only MP4s as well, and there's lots of different formats in there, but essentially, this was the way to go about it. Call that a specific endpoint on YouTube with the ID of the video, and then get back the URL for that video and start playing it. Yes. Turns out, after some more reading about getting that MP4 URL, actually Alexei wrote a really interesting blog post about how they do it. Turns out there's multiple video formats. So the one that I just showed you is the simple one for videos that you and I upload to YouTube, but not the big record labels and things like that, because they have signed videos. There's actually a cipher that is being used to decode the URL to the video. And that cipher is hidden somewhere in the actual JavaScript player and is different for every video that you watch on YouTube. So if you would want to watch one of those videos or get the metadata for one of those videos, you would need access to that cipher. And you could do that by either parsing the entire video player in JavaScript and then fetching the cipher from that. I think Alexei also talked about using a very complex regular expression to get that cipher. But in the end, there's a couple of libraries out there that allow you to get the URL for traditional videos as well as those signed videos. In summary, there are libraries that we can use to get the MP4 URL. Awesome. So next thing I did was reuse the script that I had connect to my speaker again, and instead of sending it the MP3 URL that I had on my local server, I sent it a URL to one of those YouTube videos that I got from the metadata, and yeah, I ran it and I was waiting. The expected situation would be that the speakers would start playing. The actual situation was kind of disappointing. Not a lot happens. It was playing. It was actually playing a pop. It essentially, whenever I ran the script, 1 second later, it would say nothing more. So that was disappointing. And I was thinking, now what? What do I do now? What do you do when you're already this deep in the rabbit hole? Well, you start searching. And I found on some obscure websites, I found that all of those Sonos speakers have a hidden web server that is available. There is a status server, there's a support/review server, there's a tools.htm. There's no logic in the API that this web server provides, but it allows you to look at how it's connected to the Wi-Fi, look at the supported formats. It allows you to even do a ping or a trace route to something else on your network. But I could not find any way to essentially figure out why it was not playing that MP4 file that I sent it. So time for troubleshooting. The irony, by the way, is that it was almost as hard to find a license-free picture of a rabbit hole as this entire talk about diving into a rabbit hole was. So that's a little bit of a downside. Anyway, troubleshooting. So I started thinking maybe it is that SOCO library that I was using. Maybe those 65 contributors who have been building this thing for a couple of years now, maybe they have it wrong. Of course, putting it that way, it already sounds a little bit stupid, but at this point I was thinking, well, why not? We are checking anyway. Let's see what we can do. The official application of Sonos can send a stream to the speakers. So maybe I can listen on the network and see what the request, what the payload of data that they send to those speakers looks like, and essentially replay that from a custom application. So I wanted to sniff the network, see which package were going over the wire. There is a tool called Wireshark, and Wireshark works on a lot of operating systems, and it allows you to sniff the traffic that passes your computer's network adapter. So essentially, you boot it, it installs a virtual network card, and it listens to everything that passes by your computer. Unfortunately, my app, my phone, was on Wi-Fi. My computer was on Wi-Fi, but I could still not see the traffic passing my computer. Turns out that my access point is smart enough to know where to direct the network traffic, and it's not sending all of that traffic everywhere. So that's a bit annoying because I had no way of sniffing the network, seeing what was going over the wire there. But then it hit me. I have those Unify access points, and they're all Unix-based or Linux-based or whatever. So I could use this command called TCP dump on there and sniff on the access point itself. So I started doing that. So from my Windows machine, I ran Ubuntu in the Windows subsystem for Linux, SSH'd into my access point, and there ran TCP dump and piped all the data back to Windows. It sounds mind-blowing, and it kind of is, but the command is fairly simple. It's essentially SSHing into the access point IP address, running TCP dump and telling it that we want to capture the Ethernet 0 network adapter, and all the traffic that goes from or to my phone's IP address. So essentially using this command and then piping it into Mount C users, my username to my desktop, I was able to dump data from the access point directly onto my computer. Awesome. Nice side effect is that those captures that you capture using TCP dump, they can also be opened in Wireshark. So in Wireshark, I was able to see all of the data between various devices and my speaker or my phone. And what I could see is essentially all of the packets that were sent when I, in the application, streamed one certain file or one certain radio station to the speaker. And I looked into the packets. This UI is very, very confusing and complex, but I found some menu entry that would show me the payload of one packet traced across TCP. And I found this one, where apparently my phone was sending a post request to a web server somewhere, to a media renderer /AV transport /control URL with a payload that is essentially some XML. And yes, your fancy Wi-Fi speaker uses SOAP to retrieve its data and its payloads and to do whatever it does. Now, I decoded that, put it on the next slide, and this is essentially the payload that my phone was sending to those speakers. A bunch of SOAP with a set AV transport URI method that is being called. It's passing the current URI for the file that I want to play. It's not HTTP, it's not HTTPS, it's this custom types that says X-Rincon MP3 radio with the file that is on some hosts. I can also pass in the title, I can pass in the JPEG URL to get the art in the actual Sonos application as well. And I can even pass a description of the video. So this is cool. And it gave me some ideas to try. First of all, I was searching the internet for that specific protocol, the X-Rincon MP3 radio there. Found some websites from long ago, and apparently Sonos supports a couple of those formats, but it kind of treats them all the same way. So it was safe, according to that documentation, essentially to use this payload. So I started replaying that payload. I tried MP3 URLs and I tried MP4 URLs, and I found that MP3, every time it worked, MP4 did not work. It did essentially the same thing that SOCO library did. It popped the speaker, it said something, and then stopped playing everything. So the SOCO library did not have any issues. This was kind of research for nothing, which I could have guessed if I would have thought about the fact that there were 65 contributors of that library. But anyway, I found out, I proved, I confirmed that MP4 was not working. MP3 was working, but MP4 was not. I also searched around a little bit for that DIDL light that you saw in the payloads. And it turns out that those speakers use good old UPnP, Universal Plug and Play. There's loads of documentation that you can find about that. There's even an XSD schema that you can use. Fiddled a little bit with some of the things that are in there, but I really could not get the MP4 URLs to play. So I started thinking, maybe it's the MP4 formats. So I went back to that list of supported audio formats on those speakers and found that MP4s did not have the internet radio stations checkmark. So could this mean that it could play MP4 from my phone, but not from somewhere on the internet? Then I looked at some other line in there and I saw that AAC format does have support for internet radio stations. Now, AAC format is essentially the audio codec that is being used in a lot of MP4 videos online. So I thought, okay, maybe if I have that MP4 online, I could extract the AAC audio stream from within that file and then maybe send that off to the speakers and start playing it. Could this be an option? Actually, there were a couple of options at this point. I could download the entire MP4, push it to the speaker as a local file because it didn't stream from the internet, but it did stream as a local file, so I could do that. I could proxy the MP4, transcode it to MP3, and then send the MP3 URL as internet radio to the Sonos device. But that kind of sounded like something that would work for various short clips. If there would be like a 1 or 2 minute video that I wanted the audio of, this would work reasonably well. But imagine I would search for a DJ set that took 1 hour and a half. I would have to download probably 300 megabytes of MP4, transcode it on my phone somewhere, and then send it off to the speaker. That would take a lot of time. And by the time that MP3 would hit my speaker, I wouldn't even remember which video I wanted to play. So that was not something ideal. So I decided, okay, investigate the MP4 extraction, see if there's indeed AAC in there, and send that URL as internet radio from that file. Let's talk about containers, and not Docker containers. Let's talk about MP4 containers. The MP4 format is something that you will find loads of documentation about, but it's essentially a container format that specifies how you can put different types of media inside of one file. So typically an MP4 file will have a header describing which parts are in there. And then we'll have one video, may have some audio, may have subtitles in there, may have subtitles in different languages. Essentially, that is all in there. Now imagine if YouTube would stream a 1 hour video stream with audio. It would mean that we would have to download the entire MP4 file if you would have one chunk of video and one big chunk of audio at the end. So all of those streaming sites optimize the MP4 file, and they essentially recode it in a way that there is the header that describes which parts are in there, but then have shorter bits of video and audio streams in there so that when you start downloading, you can essentially immediately start playing because there's already 1 megabyte or half a megabyte of video and audio in there. So it's optimized. So what I wanted for this exercise was to get access to that MP4 file, read the header, see which audio streams were in there, and then essentially try and stream that to the Sonos speaker. Awesome. Can I extract this to a separate file? Turns out, yes, you can. There is tooling called FFmpeg, and FFmpeg is like a Swiss Army knife for all audio, video, and recording formats. It can record, it can convert, it can stream audio and video. If you are using OBS Studio, for example, to stream something to YouTube or whatever, there's a good chance that it is using FFmpeg under the hood because essentially everything you may want to do is in there. Also extracting that AAC formats. So if you call this FFmpeg with the input of the original MP4, then copy to outputs, and extract the audio, then you will get the audio track from the MP4 container. And what I found is that if I executed this on a video that I downloaded from YouTube, I could indeed extract the audio. I could play it on my computer, so awesome. I put it on my local web server and then used Soko again to send that file to those speakers that I have. Expected result was audio playing. The actual result was no audio playing. Not even that pop, just nothing happens. Nothing would happen. This was the time where I really got frustrated. But it was also the time where I felt like I'm this deep in the rabbit hole now. This should work. There are applications that work. So let's Google and start looking at results page 25 or 26 and so on. And indeed, somewhere along those lines, somewhere far down the long tail of search results, I found some page that was interesting. I found a person who goes by the name Deadfood online, and he wrote a blog post about how he hacked Sonos and YouTube in the same day. That sounded vaguely familiar to what I was trying to achieve. So I started reading, and it turns out that he published it essentially as the idea with the research he has done, and turns out his story, his entire timeline in investigating this was so far very similar to what I have been doing. So I tried finding that person on Twitter, sent him a DM, and asked if we could work together on this. If he had information that I hadn't thought of, or I had the information that he didn't thought of. And at some point in the discussion, he mentioned it's AAC, but it's not in a traditional AAC format. It's in the ADTS format. Each atom needs a header in every frame. Each atom needs a header in every frame. Like, what the hell is this person talking about? Still, I decided, okay, that's a good tip, as good as anything. Let's Google again and let's see if we can find something about this and see if we can actually work with it. First of all, turns out that FFmpeg allows you to extract the audio track from an MP4 container with ADTS headers. Turns out ADTS is essentially AAC, but with different headers. So FFmpeg can add that. So I extracted it using FFmpeg. Then use that Soko library again to send that file to speakers. Well, essentially send the URL to my extracted ADTS audio to those speakers. Expected result was I would see audio or hear audio. And the actual result was I had audio. Yes, happy cat. Next thing that I would have to do was then think about making it an app. Because I, of course, did not want to run FFmpeg, extract everything on my PC, and then send it off to my speakers using a Python library. That would never work. So I wanted to make it an application. To start building an application, I would have to be able to connect to speakers, get the MP4 URL, extract the ADTS audio format. That was a new step there. Then send that URL to speakers. Sounds like something that an app might be able to do, right? So I started thinking about the architecture of the application, what it should look like and what it should be doing. So essentially what I wanted is that you could open up the YouTube app on your phone, click the share button or tap the share button, and then send off the URL to my application, to the main method in that application, and get that there. It would then discover all of the speakers that are available. I would select a speaker, It would then call into YouTube, get the metadata so I could get back the MP4 audio URL. I would then run something that would extract the ADTS audio. I wasn't yet sure what that would be, but it seemed like a good idea because it's a header format that is changing. So I could stream the data through and essentially write a reverse proxy in the application that I could send the URL to the Sonos speaker. This would give me a good way of streaming everything. Okay, I had a rough architecture in mind. So next up were technology choices. Should I write this as a native application? I heard there's this thing called Xamarin, there's this thing called Flutter. Some people are talking about Jetpack Compose. I had no idea. I'm a web developer at heart. I have no idea about mobile, so I was kind of lost. And I thought, okay, let's go with what I know. I have an Android phone. I know IntelliJ and Rider, and they're all the same IDE essentially as Android Studio. So I thought, okay, instead of having to learn a new IDE, let's just install Android Studio so I don't have to learn that at least, and start building a native app for my Android device. I installed it. I installed a ton of SDKs and lots of other things. Really, I have no idea how mobile developers do it. There's so many dependencies. But after installing everything, at some point, I could run Android Studio. I could do a file new project, and I saw a template. Now, this is confusing. Where do you start if you have no idea about building mobile applications? Do you start with no activity, a basic activity? Definitely not a map, because I would not need a map in there, but what do I use to start with? So I think I picked basic or something empty, something very, very simple, because I thought, okay, maybe adding things is going to be easier than removing things. Next page gave me a choice between languages. Again, I had no idea. I did some Java back in school. I can't say I'm not a big fan of Java. There's Kotlin as well. I know Kotlin because I work at JetBrains and we built that language. It's very much or very similar like C#. And I thought, okay, Kotlin is maybe nicer to go with. It's also fully compatible with Java, which means that I could write the application in Kotlin, but still consume third-party dependencies that were written in Java. So went with Kotlin, went with some very basic application. And after I finished this wizard, I got this application. Now what? Where do you start? I had no idea about mobile applications. So I decided, let's procrastinate and start with the most important thing, namely the UI, which looked a little bit like WinForms back in the days, but still I'm not a UI designer. So I thought, okay, let's keep everything very simple and build this thing using just a label in the center where I can post some status messages and then show everything in the application, and then start using it. So I did that, added that label, and this is essentially the final UI design of my application. Next up was more research. I started researching Android-specific things like the activities. What does that main screen do? How could I receive that share URL from my YouTube application and start working with that? So I looked into activities, which is essentially the screens and different activities that you can have on your phone, and intents, which are, for example, the sharing intent to receive data from other applications. Read the documentation on that. It seemed doable, so okay, fine. Next thing I did was start searching for libraries or codes that could do all of the major steps that I started thinking of. I found something that could extract YouTube metadata, including those signed URLs. I found a library that could communicate with those Sonos speakers over the network and send the URL to the speakers, change the volume, things like that. So good. I also found a library that could run a web server, which I could then use as a reverse proxy. And then the only thing that I needed was something to do the MP4 to AAC or ADTS conversion. I found a couple of things that could work, but it looked like this would need some experimentation. But still, I started with the application itself because I knew this was going to work at some point. So I started building the application itself. In Androids, every application starts with a manifest where you have your main activity and other screens defined. And in that main activity, I had to add an intent filter where I said, okay, when someone tries to send data to me, check if the scheme of the data is HTTPS, if the host is something that YouTube would do, and if the MIME type is text. Doing that, I was able to get back the intent, get back the URL from the YouTube app after I clicked on share. And I found that in my main activity, I could essentially just use the intent property, look at the extras, get a string, and get the extra text of that to get the URL from YouTube. Awesome. This worked, and I was essentially happy as can be after I deployed an application onto my phone that I could share from YouTube onto the application that I just wrote and just show the URL in that label in the center. This was awesome. This was going to work. I felt it. There's maybe one more thing that I want to highlight here. That's this coroutine scope. If you're a C# developer, you will know about async await, the fact that you can have tasks and wait for things to continue without blocking the main thread and things like that. In Kotlin, you have coroutines, which is somewhat similar. And if you want to use that mechanism, you have to derive or implement the coroutine scope. So that's why that thing is there. If you're an Android developer and I've never seen this, this is why the coroutine scope is there. Right, I built the app and then started adding packages. There's a nice plugin for Android Studio that is essentially like NuGet in C#, where you can search for libraries. So I installed something to extract the URL from YouTube. I installed Ktor as a web server. I found a library called MP4 parser, installed that thing as well to essentially be able to look into the format that YouTube was sending me and work with that. Now, next, I started implementing the next step in the application where I wanted to figure out which speakers were available on the network. There was a library doing this, but the library didn't really work. I found out, looking through the source code of that library, that it was using SSDP, the Simple Device Discovery Protocol, the thing that Windows and Mac and everyone uses to discover printers, routers, speakers, things like that. Essentially, what this protocol does is it sends a UDP packet as a multicast packet on the network to this host called 239.255.255.250. Which is a broadcast address or a multicast address that devices can listen to. You send a discover command, and we can say that we want to discover everything that is a zone player. What that is again in that UPnP documentation, but sending this datagram on the network should get back responses from the speakers. Turns out that the library, it was a bit of an older one, was sending multicast packets. Sonos has done an upgrade where they expect broadcast packets. So essentially what I had to do was change the IP address in this UDP datagram and send it to the network broadcast 255.255.255.255 instead of this one. And then I would get back the HTTP response from every speaker in the network. I would get back the services they offered. I would get back their server URL where I could send the data. So that was kind of nice. If you want to dive into the source code, it's on GitHub, but essentially this library that I wanted to use to discover speakers was working by making a very, very small change. Next thing I looked at was how can I run a web server on my Android device? Because if you start a web server from the main screen that you have on there, what will happen is if you swipe it away or your device goes to sleep or whatever, the application will stop, which means that the web server stops, which means that my stream will stop and my audio will stop working as well. So I needed to figure out a way to run a web server on the Android device. And I must say, Android has really good documentation on how you can do some things. And in there, I found that I could run a front-end service, which is essentially a part of my application that could keep running until the user, which would be me in the end, closes that service. So what you will have to do is in that Android manifest, add this thing and say, I have a service which is called Run Embedded Web Server service. In there, I could write a class. My class could host that embedded server and start and stop based on the commands that I would receive from the Android operating system. So apart from the implementation of that get method that you see on the slide here, this seemed very straightforward. Write that service, start an actual web server there, and then register it in the Android manifests. One of the next steps that I had to look into was create an MP4 or convert that MP4 to the ADTS formats. So I started looking into that and searching for different packages that are available. And I found that FFmpeg is actually wrapped, like there's tons of copies of FFmpeg that are wrapped as Java packages that you can use. So essentially I could install one of those into my application on my device, do some transcoding, essentially run that command that I ran on my PC previously, and then convert that entire stream into ADTS. The downside of doing this using FFmpeg is that I have to download the entire MP4 to my device to temporary storage, run FFmpeg to convert everything, and then keep the converted file on the device until my stream has finished streaming. First of all, for short videos, that is definitely going to work. But for longer videos that I wanted the audio from, that's not going to work because it would have to first download a lot of data, which may be slow. It would then have to do a conversion, which would be slow, and then send everything to the speaker, which would be slow. It all would also mess up the storage on my device because it would download the MP4, store maybe 250 megabytes of MP4 data on there, plus the ADTS stream on there, which would not be ideal. So I thought, okay, can I come up with something where I have 0 to virtually 0 delay between sharing the link from my app and having everything play on the stream? And FFmpeg felt like it was not going to achieve that, at least on the phone. It could on command line, but on the phone, in one of those libraries, it would not work. So I started researching MP4 and the ADTS format some more. And where MP4 is a container format that has headers and that has different types of data in there, ADTS itself is a very similar format. In MP4 and ADTS, essentially what you will find is atoms, which are parts of data, the things that you see in the tree on the left here. And those atoms would then be stored in boxes and would contain metadata about which data is available and so on. My good friend Deadfood by then has a very interesting blog post about how this works, but I think it would lead us too far. So I made a simplification of this. And essentially, if you have an MP4 with the AAC formats, what you will get is a move box. Here's some data. And that would be the header that says, okay, there are going to be 25 audio samples coming your way, 128 kilobits per second, and 2-channel audio. And then there would be a data block that has the raw binary data for those 25 samples. Next packet or next item in the stream would again be one of those headers that says, hey, there are more samples coming. This is going to be the format. And then again, the raw data. In ADTS, the header and the data is kind of combined. So instead of sending a header for 25 samples and then the data for 25 samples, what ADTS would do is have a header saying there's 40 bytes coming in. This is one sample, 2-channel audio, and then just stream those 40 bytes of data for that one sample. Then another header with, again, a specification of the sample that would be coming, the type of audio that I could extract from it and use to decode everything, and then get that going. So it's essentially repackaging everything. All the data is in the MP4 with AAC, but for ADTS, I would essentially have to combine that header block and that data block, extract the samples, and then stream all of them one by one. So I started looking into that. There's a library called MP4 Parser that allows you to for each over all of the data that is in your MP4. So I did that, and I found that there was a block that contained samples. So everything that I had to do was convert every sample header into an ADTS header. There's a couple of websites online that describe the ADTS header format. And after doing some byte shifting, lots of trial and error, I was able to write some codes that would convert, essentially write out a correct ADTS header there. It's not super rocket science, but I must say it's quite the rabbit hole to dive into it and figure out how it all works. With that, let's maybe explore a little bit of the code so you can actually see what is in there. So I mentioned that everything starts with the Android manifest, and me not being an Android developer found out that I could add my main activity in there, and I could have that intent action where I would subscribe to YouTube data that is being passed into my application. But I did not know about permissions that would be required. So the permissions, they're all documented, but I did not know whether I would have to access the Wi-Fi state or have a wake lock or whatever permission. So essentially, this section has been discovered by trial and error, just launching the application, trying it out, and then seeing if something would work or not work because I did not have the permission. So a bunch of permissions required, essentially having internet access, so I could get my MP4 URL, access to the Wi-Fi, so I could stream to my speaker on my local Wi-Fi, write to storage and read from storage. I don't think I actually need it, but I kept it in anyway, and the ability to be able to run a foreground service. Let's look at the main activity. The main activity, what it has is that coroutine scope, and it has an onCreate. OnCreate is essentially what gets called when my application starts. And in the onCreate, what I would do is set my activity status to open the YouTube app and share a video to YouTube to Sonos. This is my application name, and this was essentially update the label in the center of my UI. I would then also check for an intent, whether I should start or stop the web server. More on that in a little bit. And if I get an intent that has a YouTube video URL, I should start sharing it to my Sonos device. So what I did is check if my video was YouTube. If yes, I would launch a coroutine, essentially await some code, where I say, first of all, discover Sonos devices. The device discovery is going to be my SSDT client, simple service or simple device protocol, something like that, and discover everything on the network. I decided to keep the methods that did a multicast packet to get all of the players on my device, but then I also did a discover with broadcasts. There's a timeout of 2000 milliseconds. So when I demo the application, you will see that discovering the speakers takes 4 to 5 seconds. That is because I'm really waiting for 2 seconds for data to arrive in this case. Discover with broadcast, what it does is, again, it sends data to the broadcast address, sends a packet like I described in slides. The code really doesn't matter. It will wait for responses for 2 seconds and then essentially parse every speaker that is available on the network. Once I have those, let's go back. Once I have those, I will start my web server because I have a device, so probably I'm going to share this data to a speaker. So start the web server, build zone names from my devices because all of the devices give back metadata. They tell you which room they are in, what their IP address is, and so on. So I kind of make it nice so that I have something to play. And then I will show an alert in my application asking the user which device I want to share my data to. We select the device. And when we select one, we will finish. Finish is essentially telling Android that the application is done. We have everything we need. Now, what will happen is if I click one device, I will try and set up streaming for the YouTube video URL that I have and my selected device. What this is going to do is launch another coroutine that gets the actual YouTube metadata so that I have the metadata, where is the MP4 URL and things like that. But what I'll also do is use that data to construct the media title and the media art URL, because I want to have, now that I'm in the rabbit hole, I want to play the audio, but I also want to see what I'm playing, and I want some media art in my application as well. We're down the rabbit hole anyway, so let's get that from YouTube as well. Next thing I do is play on my device, and I send it the metadata. You will see part of that SOAP message in there. I send it the metadata that is essentially telling the player to display a title in the application that is using it and broadcast audio with a given URL. Everything is in there, a SOAP packet that sends everything to the device. Next thing that will happen is that because I started my web server, and my device gets this play URL message where I give it the IP address of my current device, my speaker will connect to the application's web server. The actual web server is in this run embedded web server service, and it can start and stop. So let's scroll there first. It will essentially start when needed and stop when no longer needed. It will also show a notification on screen so that when the web server is running, the user can actually see that the application is doing something there. It will do all that, start the web server, and then essentially wait for a request to come in from my speaker. That request is going to be a GET request for the video ID.mp4. I decided to use the video ID there and not something like file.mp4 or whatever, because the time between me sending the URL to the device and the device connecting to my server may be a couple of seconds. And if by that time I'm playing one of those signed URLs from YouTube, I would have to figure out what the cipher is there. So I decided to parse the video ID again, extracted metadata again in this web server. So I would have the actual URL to a URL that would work. Look at my metadata, figure out streams that are an audio stream. And if I have one of those, I will respond to my audio stream in the AAC formats, run an MP4 AAC to ADTS AAC converter, and just stream everything to the end user. So the server itself looks quite simple as well. Essentially parsing some metadata, sending everything off to the device again. This thing is where the magic happens. My MP4 converter, what it takes is the input stream from YouTube, then uses that MP4 parser library to parse all of the boxes in that MP4 formats, figure out where the first move block is in there, because that's after this, the headers start and the actual data starts. And once we have that, we will start for reaching over every single track that is in the MP4 formats and then write everything to the outputs. So lots of boilerplate code or lots of figuring out on how to get that. This, by the way, I didn't really write this myself. I found bits and pieces on the internet, and like we all do, we copy from Stack Overflow and random websites. So maybe this is even root in my device. I have no idea. I didn't really look at a lot of the other things. One thing that I did have to write, though, was that ADTS header writer to transcode or to replace the header that I had in there. So I looked at a page on GitHub that had the entire format described of what that ADTS header should look like. And essentially what I'm doing is for every frame that I write to the output, for every sample that I write, I read the data of that sample and then write the ADTS frame header. And what that's going to do is do some byte shifting with my original sample, get the sample rate, get the number of channels that should be streamed, things like that. And then essentially write that out as an ADTS header. So it looks a little bit like rocket science. It kind of is, but a lot of this is just bits and pieces that I found and combined from the internet. So with that, there's a couple of other things in there as well, but this is essentially the flow of the application and how it should be working. So now comes the moment everyone has been waiting for. Does the application actually work? I recorded a video with some copyright-free music, so this video doesn't get deleted from YouTube once the NDC folks put it up there. And let's have a look at it. So I have the device. You can see my player there. And what I will start doing is just use the app, share in YouTube. I will share to my YouTube to Sonos application, which will start. You see my nice UI in there. It will take a couple of seconds to discover the devices on the network. It will show me my home office and the living room, start stream. And if all goes well, there is now audio on that speaker. In the Sonos app, because we sent that artwork and title as well, you can now also see what you are playing from YouTube. So yes, everything works. Awesome. In summary, this was quite a nerd snap, I must say, but I am now able to enjoy music with my application. I can connect to speakers, get the MP4 URL, extract the MP4 audio track, send it off to my speaker and start playing whatever is in there, and everything works. Awesome. Another question that you may have is, do you actually use the application very often? I must say I used it back when I was building it. I used it to record the demo that you just saw. But ever since, I haven't really been using it because I have other sources that are in the legal sphere and just work as well. So I actually don't need YouTube, but still, I wanted to share this story. Because in summary, there's a lot of random things that you can learn along the way from just playing with technology, figuring out things as you go. There is a lot of knowledge out there on existing websites on page 26 of the search results on Google. And there's a lot of people who are maybe doing the same thing that you are doing. So maybe in your journey of learning random things, you'll also discover that there's people with similar passions or working on the same thing that you can talk with. So do that. And you as a developer, you can really build everything and anything, even if it seems impossible at first. And I think this is one of those things where I thought this is never going to work. Had a couple of moments where I thought it would work and a couple of moments where I thought it would never work. But again, you can build anything. Everything is out there. The knowledge is out there. Just go find it. With that, thank you. If there's any questions, I would love to hear. And if not, enjoy the rest of NDC.